Hello all, today in this video I am going to provide details regarding an code demo for in Python for diabetes disease classification with CSV dataset. We are going to hybrid CNN along with SVM. That is, initially we are going to work with CNN, and that CNN we are just calling as features, and that features we are just moving with the SVM classifier to detect the classification. So for that, initially we have to this code, this library's description already we have done in three video like CNN diabetes classification. Mostly in every classifications, this importing is common. So it is like a pandas, then MATLAB plot, then Seaborn, NumPy, then mostly sklearn using this classification report, pre-processing, model selection, etc. And then also we are going to describe the model. For that we need keras. We are just using keras only. In that we are going to use sequential, convolution 1D, max pooling 2D, max pooling 1D, batch normalization, activation, dropout, flatten, and dense. So already this code we have seen in the this thing I am using with the same code which we have done for SVM, ANN, CNN with the same diabetes classifier. So this is the code for that. You can just find it, check it out with the other video. Now this is the hybrid one. So as I said initially, we are just declaring the model of CNN by using two convolution 1D and then a batch normalization, dropout, max pooling 1D, flatten layer, dense layer, and to another dense layer. The input shape we are just calling it from the data set which is having two shape with into one. We are just converting it into 3D, that is we have reshaped our data set. Then the activation layer is ReLU. Then we are using the padding as same. For dropout layer we are just calling 4.4 as drop rate, and for a max pooling 1D layer we are declaring the pool size as 2. Then as it is followed by the flattened layer, then by the dense layer initially we are calling 10 hidden units, and then in that the activation we are calling ReLU, and then in the last dense layer we are just declaring only one hidden unit, that is our classifier, and finally the activation we are calling as sigmoid. Then we are just compiling it by using the parameters like optimizer as Adam, loss as binary cos entropy, and the metrics we are using accuracy. Then we are training the model by using the variables x train, y train. Then approaches we are training for 50 approaches. Batch size we have set as 32, and the validation data we are just calling the x tested variable and also the y test variable. So then once the training is done, this training or by using the x train and the x test, we are just declaring features train and features test by using this output which is proposed dot predict output, and then this features train and test we are using here. You can see in the SVM classifier we are using features train and features test, that is the output of this convolution maximum. It convolution that is CNN, we are just calling to the SVM, and then we are just finding out training it and then finding out its values. So initially CNN will run for 50 approaches. Since we gave nearly 50 approaches, you can see it has run for 50 approaches, and that output only will be called as features in the SVM dataset. So this is the output for confusion matrix, and then other performance metrics parameters are also here like precision, recall, F1 score, support, accuracy, micro average, and also weighted average. So this is the output for hybrid CNN and SVM by using uh, diabetes data set. So here we are using with the CNN. Here you can see with CNN we got only 71% accuracy, but with the hybrid CNN and SVM we got nearly 73% accuracy. By using hybrid CNN and SVM we are getting some improvements in prediction rate. So in the next video we can see some other demo videos regarding MATLAB, Python and Vega. Thank you.